and that's how the snapshot mechanism works. Coming to the recoverability block level application, I think the block level application is what is the underlying technology that's being used to replicate data across the site. So when it comes to recoverability or DR, nowadays data replication across site is mandated operation specifically for the case where data size that has to be replicated is very, very huge. Few years back, data replication was purely dependent on the application layer to keep the data synced across two data center. Example, syncing the static content using, let's say, rsync or the robocopy daemon utility, syncing or replicating your ADLDAP data through the ADLDAP sync. Same is the case for the databases as well. But now we can leverage storage application tool to replicate data across two data centers. Replication could be on a broader level. The replication categorized into the host base and the storage base. So I'm just focusing on the block level replication. I'm not at all talking about the high level replication. Not considering the application based application, which is more like a file system based application. So the host base and the storage base is purely a block level application. So host based application is where you have to install agent on individual servers to make sure that the agent work or do that replication for you. So in that case, you can have one-to-one replication, or you can have many-to-one replication. Whereas in block level or in the storage based application, it basically the replication is get done at the storage layer or storage array layer. So here, rather than the file system get replicated, it basically the storage LAN or the volume that actually gets migrated. So any virtual machine that actually is being deployed or being cut out from that particular LAN or volume will automatically get migrated as part of that particular LAN replication. So replication can again be categorized into two parts based on whether you need a synchronous or asynchronous. We'll talk around both things one by one. First, we'll see how the host-based application and the storage-based applications are different from each other. So if you go with the host-based applications, in terms of the benefit that we'll get is that host-based application is not the storage agnostic. So if you, let's say you have two data centers using one data center using NetApp storage, another using EMC storage, then there will be a huge challenge in terms of getting data getting replicated at the block level. So host-based application is the best way through which you can do it in such scenario. You can relate both synchronous and asynchronous. You can schedule both ways. Data, in this case, data can be reside local to the storage or local to the server, or could be on storage. It doesn't matter because the agents are responsible which are lying in the file systems to replicate the data. So it generally do not impact that with the storage or the hardware update because it's an agent-based mechanism. In storage-based application, let's say you have the same single vendor across both the sites. I think this is the best way to do the application. So these are the vendor agnostic. So vendor dependent. So you can go using this route to actually replicate your data. There will be no performance burden because they are not dependent on the host. It is done at the storage level. So the performance burden is generally done at the storage end rather than the server or the host end. It does not depend upon the operating system or the file system as all the data that gets replicated is the block data. You really don't have to configure any agents on the servers, so there is no overhead of installing any agent across tons of servers in case that has to be deployed across enterprise solutions. The downside of it is that in host-based application, since it's agent-based, has to deploy on the host side, it actually consumes a lot of compute power into the host. It depends on the operating system. You really need to make sure that the correct agent is installed on the type of operating system you are running for the application. And it's generally not suitable, like I said, that for the enterprise class where let's say 100 of server has to be replicated across the two sites. In case of the storage-based application, it's vendor locked in. You cannot leverage this piece of replication across two different storage vendors. The cost is really, really high. The licensing cost to purchase the replication is additional, like additional cost over and above for that we procure for the storage hardware. All the data that you really want to replicate has to be resigned on the storage array. You cannot have any data that is lying into the local servers. Best fit. So a host-based application it does fit in the environment which are using multi-vendor storage, where you really want to ensure that in some cases you want to do a sync replication, in some cases you really want to do async replication, and if let's say if your use cases is to get a single data get replicated to the multiple target or the vice versa, then host-based application is the best way to do it. Storage-based application, let's say you are a single vendor partner, or you really don't want to invest to learn multiple technologies and you are preferred for single vendors, then I think this is the best technology that you can go for. It basically replicates one-to-one, so you cannot have replication from one server to multiple storage, so one storage to multiple storage. It can be cyclic, but it cannot be one to multiple. In terms of synchronous and asynchronous, when to go for synchronous application, when to go for asynchronous application, I think when it comes to the distance, as I said, that latency is the major factor in deciding whether you really want to go for synchronous or asynchronous. Up to 100 miles, latency less than 5 milliseconds is something we can go for synchronous. Asynchronous, if you really want to have the global application done, then you can go for the asynchronous across two regions, something like that. With synchronous application, you really need to have a huge bandwidth, because the time to take to commit the data to the other data storage will basically can hit your performance. So you need to make sure that you have less latency and more bandwidth to go with the synchronous application. But in asynchronous application, there is no hard boundation to it. It can vary from with the change in the rate of data. In terms of the recovery point, synchronous is always replica of your master or your primary data center, where asynchronous is always some downtime to it. Best fit, if let's say you have a high bandwidth to low latency, application performance is not primary concern, where you really need to have a requirement of RPO of 0, then you can go with asynchronous. Whereas asynchronous, where you have to have two data centers across two different regions, let's say one in APAC and another in northern region or the European region, then you can probably go with this particular application type.